Hello, everyone. Welcome to today's webinar, Multi-Terabit GTP Processing for Mobile Service Providers. My name is Judy Ash, and I'm the head of corporate marketing here at Big Switch, and I'm your host today. Joining me is Praful Baidasna, our Director of Product Management. As always, we go through the presentation. Please feel free to ask questions using the Q&A box on the webinar dashboard. If you're watching this as an on-demand webinar in rebroadcast mode, and you have questions on the topic that we're talking about today, please email us at info@bigswitch.com. We've also provided you with a number of handouts for today's session, and you can easily download them from the Handouts tab on your dashboard. Praful, I'm going to hand it over to you to get started. Thanks.
Thanks, Judy. Good morning, everybody. So today I'm going to talk about Big Monitoring Fabric and more specifically what we are doing with GTP correlation and multi-terabit processing of GTP correlation traffic at mobile carrier networks. A brief update before I get into Big Monitoring Fabric. You all must be knowing that at Big Switch, our vision is to provide next generation data center networking and monitoring solutions for our customers. So with respect to monitoring, the question may arise that what does next generation actually really mean? So the next generation network packet broker to us is something which is different from the traditional network packet broker. The traditional network packet broker is typically box by box by box based, and because it is box by box, it is hard to manage, it's complex. And finally, it's proprietary and expensive because you're getting the hardware and software from the single vendor. On the other hand, what we are doing with our next generation approach is we are following a hyperscale inspired approach. So the hyperscale guys like Microsoft, Facebook, Google have come out with this approach where they use open vendor switches, which is what we use. They have a controller that manages the open vendor switches as a fabric, which is what we do. And finally, they build architectures that can scale. And this is what we do. And given that we are using the open vendor hardware, we can now lower our cost by up to 50% or even more in some places. The goal for doing all of this is because we've seen a pervasive need for customers to have complete visibility of their network. And the reason for that is if you can't see what's happening in your network, there is no way you can protect. And this is something that traditional network packet brokers cannot really do. And let me explain a little bit why I say that. So if you look at deployments for legacy network packet brokers, you will see that typically the network packet brokers are deployed at the core of the network because it's very expensive, and because it's very expensive, what customers are thinking that, hey, by putting it at the core, I will get all the traffic that passed through my network. Which is true if your network flow is always north-south. But now that we've realized that most of the applications are now east-west bound, typically 80 to 90% of your traffic, by just tapping at the core is not going to give you the visibility that you want. And then when customers have realized that, they will buy more network packet brokers. If your data center grows, you will buy more network packet brokers and also the tools that are connected to the network packet broker. And then if you look at it from all the boxes, if you look at it from the production network, now you have a set of tools only for a particular band of your production network, which basically leads to highly inefficient tool usage. If you look at the network packet broker perspective, you will see you have a lot more boxes. That means a lot of things to manage, a lot of things to troubleshoot, and a lot of things to orchestrate when you want to make any changes, which gets complex and expensive very, very quickly. But the kicker here is if you look at it from the tool's perspective, and here my mouse is at the lowest band of the tool. If I look at this tool, he just sees traffic from this lower band of the production network. Now the question is, how do you expect a tool to make an intelligent decision about what's happening in your network by just looking at a piece of your network? The answer is you can't. So despite all of this investment, you still don't have, as a customer, the visibility that you really need and for your business agility. So let's look at how Big Switch, or being more clear, how Big Monitoring Fabric solves these problems. So what we are doing is we have a controller based a logical network packet broker. So open vendor switches managed by the controller, giving a view of it being a logical network packet broker. Because of that, you can see that the tool silos that we had in the previous slide are now gone, and now you have a single centralized tool farm, which has complete visibility of your production network. Because of this, any point in your production network can actually send traffic to any or every tool in your centralized tool farm, which gives you the pervasive visibility that's required in today's environments. And this is what the next generation network packet broker brings for our customers. Now, if you're looking at the key value props for the big monitoring fabric, the top of mind would be it's an open vendor. We've seen a lot of customers come and say, hey, we want freedom, we want flexibility, we do not want to be locked into a particular vendor. With our open vendor SDN approach, you now have that ability to do that. We operate with Dell switches, we operate with HPE switches, we operate with Acton switches, and as we go in future, we will have a lot more other switches too. Now, if you look at it from the architecture perspective, what we're doing is we're taking these Broadcom-based, silicon-based switches, which are typically production switches. They are deployed everywhere in your leaf or spine of your production network. These switches are reusable. You can use it for production use, you can use it for monitoring, and they are also part of Facebook's OCP project. That means you can use it for any of OCP projects that you are currently working on. That gives you a lot of reusability. It gives you the best of breed hardware, and it gives you a pay as you grow flexible fabric architecture that obviously helps you with your CapEx costs. With all of these, you now have a scale out and simplicity, because you can add more switches one by one into your fabric, but your management points will always be a controller, which gives you immense simplicity, which again, your traditional network packet broker solutions do not provide. And finally, we have telemetry inbuilt into our product, which gives you real-time or historical analysis with regards to your production network, what's happening, as well as with regards to your monitoring fabric. So with these four key points, we've seen our customers like big monitoring fabric way better than traditional network packet broker solutions. Here's a quick look at what Gartner talks about, and their market direction guidelines basically say all the same thing. For example, they are saying no more CLI, you need to use API. Our controller-based architecture is completely REST API based. The CLI of the controller, the GUI the controller supports, are all actually calling the REST API internally. So there is no such thing as a function that would not have a REST API equivalent in our architecture. So we call that our REST API first principle. With our product, again, you're seeing that the value is shifting towards software by leveraging open vendor switches, by leveraging x86 servers, so on and so forth. We are building fabrics. We are not talking about box by box management, and then we are using open standards and multi-vendor interoperability. So we are completely online with what Gartner is seeing the market direction is going towards. Here are some of the customer validations, which basically echo the same points that I've talked about so far. Basically, it is agile. It saves them time. It's scalable. It's flexible. You can scale from 1 gig to about 100 gig. It performs better than the competition. And it also provides flexibility and also more visibility with regards to what's happening into the network. Now, with that high level, let me talk a little bit more about the big monitoring fabric architecture, which is going to be very key for you to understand how our GTP correlation solution is actually super cool. So this is how a big monitoring fabric out-of-band deployment is. We also have a big monitoring fabric inline deployment, which I'm not going to go through in this session, but you are free to watch our previous webinars which talk about big monitoring fabric and line. So what you see right now should be fairly straightforward. What we've talked about on the left-hand side is the production, right-hand side is the tool, and in the center is a scalable fabric of open Ethernet switches managed by a controller. The key point here is this fabric is scale out. That means you can start with one switch, add another switch, and build the fabric as you need. This scale out architecture, and as you're adding more switches, you are not increasing the touch points because all the management, all the orchestration, all the troubleshooting is always done from your controller, which is going to be a single pane of glass. Now you can also add in a service node, which is basically an x86 based server and typically used to provide advanced packet modification functions. For example, deduplication, packet slicing, packet masking, GTP correlation, so on and so forth. Now, if you did have legacy network packet brokers, you can also attach them to this network, to this fabric, as third-party service nodes. And that way you can get these advanced packet modification functions provided by these network packet brokers within the big monitoring fabric. In fact, adding them as third-party service nodes is actually a better architecture and provides much more efficient use of your legacy expensive network packet brokers. Now, this gives you a complete or pervasive monitoring for a single data center where you have your production network and your tools, centralized tool farm. What if you have data centers which are across sites, locations, branches, POPs, so on and so forth? Well, you can still add a few switches there, where the filtering will happen at the remote end. We'll create a L2GRE tunnel, get it here, and then send it to the centralized tools. Again, here, please note that it's the same controller still managing all the remote switches. So from your perspective as a user, your management touch point will always just be your controller. And then as your workloads move into the cloud, we will extend the same architecture to the cloud. So this gives you a very good high-level view of what Big Monitoring Fabric out-of-band architecture is all about. So let me quickly talk about a little bit about the various important pieces of this architecture, and then we go straight into GTP correlation. So from the controller, it is REST API based, fully programmable. It's resilient because you have HA. We support headless mode in case the controllers do land up going away or getting disconnected from the fabric. The fabric still works, so it's very resilient. We have RBAC built in. And finally, it will provide you the single pane of glass management, which gives you the simplicity for users. And if you are a power user and you want to do scripting, it does give you the REST API based approach to program and build scripts of your own from the controller. Now, with regards to the switches, again, these would be open vendor switches. It could be Dell, HP, Acton switches, 1 gig through 100 gig, all Broadcom based silicon, various different form factors. But the cool part about all of this is a pay as you grow model. You can start small and then scale up to as big as you want, building your single logical network packet broker. And these switches are reusable across multiple different use cases. The scale out capability of the fabric is again shown by the big monitoring fabric service node. So you can add one service node to get those advanced packet modification functions. And as you need more and more bandwidth, you can keep adding more and more service nodes. The important part to note here is while you're adding more service nodes, you are not increasing your management touch points. Your management touch point should again always just be your big mon controller. So they will be automatically discovered as you connect them to the fabric. That's pretty cool. Also on our service nodes, we have a 4-port 4x10 gig service node as well as a 16x10 gig service node. Now moving on to analytics, this is where the telemetry functions and functions which talk about capacity planning, security views, performance views like top talkers, which hosts are running what OSs. If you have rogue DNS or DHCP servers, we can find out about this. Health views, alerting, all of that is available here. And this is again in a historical time series manner. So you can go back in time to see what happened at a particular point in time. This is a pretty cool function which traditional network packet brokers do not have. So now that we've covered the big monitoring fabric architecture in a little bit of detail, now let's jump right into GTP correlation. You all must be familiar with how the telco carrier network looks, and this is a snapshot of how it looks. With regards to GTP correlation within the telco/carrier environments, there is just one main requirement, and that is all traffic, be it the control plane traffic or the user or data plane traffic, for a given subscriber should always go to the same tool instance. And there's a very good reason for that. It's because each tool instance wants to be able to assemble a complete view of what the subscriber experience is all about. And that can only happen if all traffic for that particular subscriber goes to the same tool instance. Now, the definition of the subscriber varies by different organizations. It could mean MZ, it could mean TEID, it could mean MSISDN or IMEI. But the final goal is always the same, that all the traffic of a subscriber should go to a single tool instance. And why is this needed? The use cases that we have seen is mainly for troubleshooting or monitoring use cases, for if a subscriber is complaining that he's seeing slowness in the network, so on and so forth, lawful intercept use cases, or even from the telco's perspective with regards to identifying what the subscriber bandwidth is, how is he using it, billing, what applications are going through the network, so on and so forth, to give them more details with regards to how they would want to price in the future. Given that, if you look at the current scenario from the telco's perspective, they are continually seeing that the number of subscribers are increasing, and they are also currently seeing that the volume of traffic is also continually growing. What this means is that the amount of data that needs to be correlated is growing and growing and growing. Now, if you contrast this with the current GTP solution that are in the market, they have, when we've talked with our customers, they've told us three main points why these current solutions do not really help them. The first one is performance. So irrespective of the interface bandwidth that's available, the GTP correlation throughput is way, way lower than the interface bandwidth. It's close to about 10% of your interface bandwidth speed. So if you have a 10 gig interface, your correlation is about 1 gig. That means that if you want to correlate hundreds of gigs of traffic, you're going to need a lot of expensive network packet brokers. The second thing is, even if they were willing to spend and buy all of these expensive network packet brokers, how do you scale? How do you track sessions across all of them? That's not going to be easy, because finally you want to make sure that all subscriber data, particular subscriber data, all traffic goes to the same tool. So as you're adding more and more NPBs, how do you make that happen? How do you keep the trackability of the subscriber sessions and make sure that the traffic is flowing correctly? And then finally, it is expensive. Now with big monitoring fabric, so you will have your big monitoring fabric controller, you will have the open Ethernet switch building that big monitoring fabric, and then you will attach the service node where your GTP correlation will be done to the big monitoring fabric. So single service node, let's say 16 ports of 10 gig will give you 160 gig of bandwidth. So the first point, in contrasting with the performance of traditional competitor solutions, the throughput from our service node for GTP correlation is close to 90% of the interface bandwidth. So if I have a 160 gig service node, you will expect 90% of the 160 gig to go through correlated, which is way better than any competitive solution. So that's number one. But you will say that, okay, this is still just 160 gig of the service node. What if I want 320 gig? Because that's what large telco providers are looking at. They are looking at millions of subscribers and a huge amount of traffic that needs to be correlated. Well, as I explained earlier, you can keep adding more service nodes, and you will lag them from the big monitoring fabric perspective. So now any traffic that comes in will get hashed across these service nodes, and then they will get automatically correlated before we send them out to the tools. So this scale-out architecture from leveraging the big monitoring fabric service node gives you value in terms of price performance, in terms of what the throughput is, and in terms of scale out. So you can build as you want, as you need. And while you're doing that, it's still going to have the controller as your single pane of glass as the architecture. So you are not increasing the complexity as you are scaling out, which is what was the big monitoring fabric architectural key design. Now, with that said, I wanted to show you some quotes that we've gotten from various people. So this one is from Stephen Collins. Stephen Collins, who is the principal analyst at ACG Research, and he basically has a lot of experience with deploying GTP solutions at various environments. And he said that this was something that has surpassed any solution that he has seen with regards to GTP correlation deployment in any place in his experience. So we provide a unique and a cost-effective solution that gives you the scalability and performance that has not been seen before. We also have another quote from Mr. Akira Kaneko, who is a systems integrator for service providers in Japan. And he also validated it, saying that this is an innovative solution which has not been seen previously because of the way we built our architecture and leveraging the big one service node. The one question that you may guys have is, if the service node is an x86 server, how do we get such a good throughput? So there are two aspects at play. So one is the service node, while it being an x86 server, is using an DPDK powered application that we have built that gives you almost line rate performance through the service node. That is our secret sauce of making this very high performance. So I've talked enough about what GTP correlation is with regards to the architecture, with regards to the scale. I'd like now to take you through the demo, and for that I will give it to Gina.
Hello, I'm Gina Fallon, a technical marketing engineer at Big Switch Networks. I'm going to be going through a GTP correlation demonstration today, but before I get started with actually doing configurations, I wanted to set the background. At a high level, the workflow is pretty simple. You configure the GTP traffic inputs, otherwise called the filter interface group, then configure the GTP service, which includes the ports feeding the traffic to the correlation service, what parameter you want used for correlation, like NZ or IMEI, etc., and then the delivery interface link aggregation group, where your GTP monitoring solution is actually connected and ready to receive the correlated optimized data. Finally, you put it all together in a policy. This policy takes traffic from the filter interface group, sending the GTP traffic to the delivery interface group after being correlated appropriately by the GTP correlation service as defined. Of course, telcos have spent a lot on building a huge and scalable infrastructure, but for the simplicity of this demo, we're going to use a much simpler setup and approach. Basically, we're going to be generating two different streams of traffic. One is going to be the control plane, and the other is the data plane. So those two are then going to go into the big monitoring fabric, where they're going to be sent over to the GTP service and correlated in by 20 different unique IMSI, and then ultimately it's going to be sent out to the 2 different tools where 10 subscribers will go to one of the tools and the other 10 will go to the other tool. The tool itself that we're going to use to show you how it correlates correctly is ultimately going to be just Wireshark. Now I will start with the demo. I will start by going through the GTP Managed Service configurations. This is as well already been configured. I will at least have us look at what those parameters are. I get to pick the switch, and there is again that link aggregation group that I predefined earlier. The action itself is going to be GTP correlation. I've got a timeout window that I can configure, and then as you can see, I've already picked the IMSI group as the type of correlation that I want to do. If that predefined group isn't sufficient, I can go ahead and create another group right on the fly, and it'll add it into those predefined groups. Again, I'm not going to do that here. I'm just going to go back to that IMSI, and that's basically it. Now, this is where we're going to take all of those different things together and put it together in a policy. So I'm just going to name it GTP Correlation. Next, I will go to the rules. You can see there are predefined match rules for different common types of traffic. However, we're just going to go ahead and use any. And then now I'm going to go to the feeds. I created that interface group. So I'm going to select the interface group tab, hit plus, and now there you can see I'm going to select that filter group called traffic filter that I already defined earlier. I'm going to append that. I can hit next. And now I'm actually configuring that delivery port. So where those instances of the tools have been connected. And you can see I'm finding that predefined one I did earlier, which is the temp lag. And I append that. And then last is that managed service that I want to send it to for correlation. So if I pick, there it is. It's already been defined. And then once again, I'm going to append it. Then the last field is just to go through the summary of all of the different configurations. I'm going to save that. And if everything is right in the world, I've got all these nice check marks saying everything has been installed, the policy is ready to run and go. And now we'll go on to the test portion. So for traffic generation, we use Ixia. And if you remember from that diagram at the very beginning, as I said, we're going to use 2 different network feeds, one for the control plane and the other one for the data plane information. And then within those 2 data feeds, we're going to have 20 unique IMSIs. So you can see here where it's 20, and then each of those unique IMSIs are also going to have a unique source IP address. Each of those is going to increment by 1. So basically, they're going to have matching last numbers, so that the IP address is going to be .1 for the first, and the IMSI number is going to be 1, and then 2 is going to have .2 for the IP address, and so on. And then now I'll go back and get the actual test started. So it's going to take a few seconds for it to clear out the statistical data from the last test that was done. That's what you're seeing here. So there we've got it closed out, and now we're going to start generating the traffic for our new test. I'm going to go back over and look at the stats to see, refresh that so we can see what packets and byte count we get. Now if I go back over here, you can see it's finished. Okay, so now we're going to open up those capture files that we got through TCP-dump. And first we're going to apply a GTP filter that I've already got set up. So you see there's the GTP filter. I'm sorry, it's a display filter. Once that's applied, you're going to see in this first capture there is very quickly only 10 packets. So again, this is going to represent the control plane data. I'm going to also expand down in the details of my capture to show you that MZ number. So here's that MZ number. You'll see it's 2. Also, again, it's partially, well, it's 100% because of the way ICSIA generated the traffic. The MSISDN number is also very correlated by number, and the MEI. So you'll see it's 2, 2, and then 20. It just adds a 0 on the end. As I said, to make it easier to make sure that this is all correlated properly, I'm going to pull up Notepad, and then we're going to just make a list of the IMSI numbers that are in this particular capture file, which again represents that one instance within a load balance group. So let's go ahead and do that. So this starts at 2. I'm going to go down 1 packet, and now I have 4. And then 6. Oops. And next is 7. And 10. And 13. And 14. 16. 19. And 20. So I have 10 different unique NZ identifiers in this capture. And then to make sure that all of the actual data plane traffic is here and is only here, I'm going to go into stats and endpoints. Wireshark has already given me a record that shows all of the IP addresses that are in this capture. So then you can see really quickly that they actually match what's in my list. So you'll see there 2, 4, 6, 7, 10, 13, 14, 16, 19, and 20, and only those IP addresses. So now let's go ahead and look at that second capture. So if you remember, I had the 2 tool instances that were in my lab. We're just going to repeat the same process. I'm going to first apply the GTP filter, and you'll see again it's 10 packets. We're going to go through that list again. I'm going to create a second section on here. You'll see it does not repeat any of those that are in the first section. So let's see, this first one is, so the first one is 1, then 3, 5, 8, 9, 11, 12, 15, 17, and 18. So again, right off the bat, you can see if I pull this open a little bit more, it is 10 other numbers, and it does not repeat any of the numbers that was in the other capture file. So I've separated the control plane into each of the 2 different tool instances, and now I'm going to look at those endpoint IP addresses, which represents the data plane, and compare those with my second list, and you'll see again they match. So there's 1, 3, 5, 8, 9, 11, 12, 15, 17, and 18. So each of those 2 capture files, which represent my individual instances of my monitoring tool for my smartphone environment, they have received completely correlated data between the control plane and user plane data. That concludes our demonstration of our GTP correlation solution.
Yes, thanks Gina, and thanks Profil. Lots of great information shared about Big Monitoring Fabric and its capabilities in GTP correlation. You can ask a question using the Q&A box. If you're in video rebroadcast or on demand, email us at info@bigswitch.com. And don't forget to download the handouts from the handout tab. We do have a couple of questions coming in, Profil. First online is, so the new engine can understand GTP and it's not, quote, only limited to the offset, length, and pattern.
Yes, that's correct. So the offset length and pattern was the limitation of the ASIC on the Broadcom switches. But given that we are using the service node, we now have the capability to do full-scale GTP correlation at capacities and throughputs never seen before. So that's absolutely correct, yes.
Cool. And just to confirm the switch platforms, it works on Dell EMC Z9100 32 by 100 gig switches.
It works on all switches that we support in our HCL. So it is the Dell EMC switches, it would be the HP switches, it would be the Acton switches. It would work for all of them. So the switch fabric would basically be acting as a conduit to send traffic to the service node. The GTP correlation would be happening on the service node, leveraging the x86 CPU that's present on the service node, along with the DPDK based applications that we have written.
Great. So a few more. You mentioned that by placing the traditional NPB on the side as a third-party service node, it's a better architecture. Can you explain how?
Okay, that's actually an interesting question. So if you look at a traditional deployment, you'll have your production network on the left, you'll have your network packet broker in the middle, in this case, the traditional network packet broker, and then you'll have your tools at the side. Given that your production network traffic is increasing, you're basically, the traditional network packet broker is now becoming the single central place of bottleneck, so to speak. So what that means is you either have to buy more network packet brokers or you have to limit the number of monitoring that you can do. Now, by taking that expensive traditional network packet broker and putting it on the side and putting big monitoring fabric in the middle, now you have a more value-based fabric in the center taking the bulk of the traffic. And only the traffic that needs, let's say, advanced packet modification functions, you would send it to this legacy traditional network packet broker. That way, you're making more efficient use of your expensive resource. And let's say if you need more of that functionality, you can obviously go and buy more service nodes that we have, the Big Mon service nodes, to work along with the third-party network packet broker. This is a very good way for you to make more efficient use of your legacy network packet broker. And at the same time, as you're scaling more and more, you can buy big monitoring fabric service node and thus reduce your vendor lock-in, stop paying the expensive proprietary functions that the legacy network packet broker provides with the big monitoring fabric service node.
Great. So what will happen if the service node fails? Does the architecture also support high availability for service nodes?
Oh yes, definitely. So the architecture that we have, the fabric, the switch fabric, as well as the node fabric are highly resilient. And the cool part about all of this is completely up to how a customer would want to design. You can design resiliency with regards to your switch fabric. You can say, okay, I want resiliency for up to 3 links, or you want to have more links. And the same thing you can do for the service node. Given the scale out architecture that we have, you define what sort of resiliency you want to have, and we can make it happen. So this gives a lot of power in the hands of the customer to define how they want their network topology to look like for monitoring.
Great. I think the GTP correlation solutions are indeed what telcos are looking for. Congratulations. The question I have, though, is can you do subscriber whitelisting too?
Yes, that's a very good question. So along with the traditional GTP correlation, we do offer a lot of other features that are associated typically with GTP correlation. For example, I can do load balancing based on TEID or MZ. I can do filtering of traffic. I can do sampling of GTP traffic, and I can also do whitelisting of subscriber traffic based on either MSI SDN or MZ or IMEI or so on and so forth. I can also do filtering based on APN, and we are now looking at bringing in another feature that we'll talk about in the next webinar. But overall, yes, we have a lot more related functionality along with GTP correlation that's present with the GTP deployments.
Great, great. Thank you, Praful, for joining us today. We really appreciate your time. The topic has been excellent and very well overviewed for the audience. For our audience members, thank you for joining us today. If something we discussed has piqued your interest and you really want to know more, just head over to our website at bigswitch.com. And again, as a reminder, you can absolutely send us an email at info@bigswitch.com. Definitely make it easy for you to get started with our solutions with two options to trial. One is a free community edition software for Big Monitoring Fabric or Big Cloud Fabric, and you can get access by registering online. Second is a very vibrant and growing community in our Big Switch Labs environment, which makes it easy for you to trial out several modules. Modules for all of Big Monitoring Fabric and Big Cloud Fabric are available in a lab environment. It's our sandbox, trialing use cases from your network, and you can experience Big Switch bare metal SDN solutions firsthand right at your laptop. Taking a test drive is one of the best ways to experiment, no risk, no fees, all for free in a community of about 6,500 network experts who are now in the environment. So visit us there for labs.bigswitch.com. And there's a handout available as well that helps you understand the details of that. Let me close with what's our schedule for webinars. We actually have a pretty great lineup. Wednesday, February 14th, Valentine's Day. We'll be talking with David Robinson, who's the CTO of STT Connect, and he's going to talk about how they've used Big Cloud Fabric, Big Monitoring Fabric to create a web scale cloud offering with a software-defined technology from Big Switch, leveraging next-gen networking to unlock the power of hyper-converged infrastructure. We are partnering with SDX Central for a report webinar, and that's scheduled for Thursday the 15th. And finally, a favorite topic amongst our audience is the container topic. It's a hot topic in general just because of the growing number of applications that require agility in the network and need a new way to quickly spin up applications. We have Aqua and Portworx with Big Switch talking about that on Wednesday, February 28th. Please join us for any or all of the future webinars. Watch your email for registration details or check out our webinar catalog. Have a lovely day. Concludes our presentation. Thank you for joining us.